Imagine you have a process that works 95% of the time, and you need it to succeed 10 times in a row. What are the odds of that happening? Let's break it down. First, the math. Since the process succeeds independently for each event, the probability of all 10 events succeeding is the product of their individual probabilities, 0.95 to the 10th power. Punch that into a calculator, and you get about 59.87%, so just under a 60% chance of success for 10 flawless attempts. But what about failure? The flip side is that there's a 40.13% chance of at least one failure in 10 tries. That's because 100% minus the 59.87% success rate gives us the failure rate. Now, why does this matter? If you're a manager setting performance goals or assessing system reliability, this calculation can help you set realistic expectations. For example, if your goal is a perfect streak, be prepared for it to take more than one set of 10 tries on average, about 1.67 sets to be exact. Here's the big takeaway. Even highly reliable processes can fall short over multiple trials. So plan for variability, adjust your expectations, and if you can, build in some flexibility. Because in the world of probabilities, perfection is possible, but not always probable. Let's apply what we've gone over. Imagine you have a production line that produces a critical component for a spacecraft. Each unit has a 95% chance of passing inspection. Now, let's say we need to produce 10 perfect units. What are the odds of achieving this? Since each unit's success is independent, the probability of all 10 units passing inspection is 0.95 raised to the power of 10, which equals about 59.87%. This means there's just under a 60% chance of producing 10 perfect units in a row. Conversely, there's a 40.13% chance that at least one unit will fail. A single failed component could disrupt the entire mission, leading to delays, increased costs, and potentially safety hazards. This example highlights the importance of understanding the impact of compounding probabilities. Even highly reliable processes can experience failures over multiple trials. To mitigate this risk, it's crucial to implement robust risk management strategies, such as redundancy, contingency planning, and continuous improvement processes. By acknowledging the inherent variability and planning accordingly, we can increase the likelihood of success and minimize the impact of potential failures.